Hello, everyone. My name is Rachel Kelly. I'm a climatologist with GLISA, and I am here to discuss a few of GLISA's tools and resources with you today. Before I get started, I want to give a big thank you to the ELF Small Grant Team for their hard work. It has been truly inspiring to watch them work over this past year and a half, and I am just very proud of what they've been doing and very thankful to be a part of it today. So thank you to the team, and thank you for all of you for coming to listen to my recorded presentation. So a little bit about GLISA. GLISA is one of the nation's climate adaptation partnerships, or CAP teams, which is the new name for the Regional Integrated Sciences and Assessment, or RISA program. That's where our GLISA acronym came from. But with the national name change, this is why we no longer use that full acronym. So kind of like Madonna, we are GLISA. The CAP program is a network funded through NOAA Climate Program Office and is comprised of over a dozen different regional teams across the US. And our mission is to help those communities build lasting climate resilience through sustained research and engagement. Contrary to what this map says, our service area is not just the Great Lakes Basin, but includes the entire extent of all eight states that border the Great Lakes and southern portions of Ontario, Canada. GLISA is housed at the University of Michigan, and we have institutional partners at Michigan State University, University of Wisconsin, and the College of Menominee Nation. GLISA works at the intersection of research and service to help bridge the gaps between science and decision-making, and ultimately help practitioners use and understand climate information to better plan for and adapt to climate impacts. We have a team of physical and social scientists that work together to synthesize research and findings on emerging climate issues. We develop usable climate information, resources, and tools to help apply that information to decision making. And we also facilitate various trainings or collaborative activities. Today, we are going to focus on two of the tools that GLISA has, and they're highlighted here. I do have the link to GLISA's website at the end of my slides, but these QR codes will take you to those tools if you want to follow along. So we have the Great Lakes Climatology and CHAMP. These are two tools I was fortunate to work with the small grant team to kind of familiarize them. So they are near experts on them as well. But I'm going to do a quick walkthrough to highlight what we have here. So we are going to start with our Great Lakes Climatologies. This is GLISA's homepage here. And this is where you will find the Great Lakes Climatologies under our resources and tools right here. Okay, so here's our Great Lakes Climatology tool. This tool was developed in partnership with the Office of the State Climatologist. It provides a quick interactive way to find local climatology information for those within the Great Lakes region. The summaries are available for stations, climate divisions, which are usually made up of multiple counties, and there's also a summary for each of the Great Lakes themselves. The data pulled into this tool can help practitioners and other decision makers in the region better incorporate climate information into their future planning. Within the climate summaries, you'll find a description of the climate accompanied by helpful visuals like graphs and data tables. So this is the home page for the tool. And down at the bottom, it does provide a quick how to use the interactive climatology map, as well as a description of each of those different options that we talked about. But I am going to kind of walk you through briefly on how to use this tool. So here's the map where you'll be selecting which location you have of interest. You can see we have different symbology for each of the options. So the stations are marked as red dots. The Great Lakes are marked as these little waves in circles. And the climate divisions are blue polygons with a blue shading. So we're going to start with a station. I do want to point out that you can filter if you want to look at just one of the types, or you can search up in the search bar. So we are going to take a look at Muskegon, and you search and it'll pull you in there. And you can see I already have them open up here in my window, but you can click on the dot. I like to recommend right-clicking and opening the link in a new tab. If not, it'll open it in the same tab. And if you're looking at multiple stations or Great Lakes or divisions, I think it's just nice to do that right-click and save yourself a little bit of time. Okay, so this is our station climatology. It starts out with a nice overview of the area, kind of discussing the climate. And then as you scroll down, it discusses where the data is coming from. So the data used for these station climatologies is from the National Climatic Data Center, or NCDC, and they're a part of the Global Historical Climate Network daily data set. We also have these jump bars, so if you're looking specifically for temperature or precipitation, you can move quickly there, and it also lets you jump back to the top into the station map. So I'm not going to go through all of this data in depth, but we'll do a quick kind of functionality overview. So this is an example of one of our tables. I do want to highlight the time period should all be marked. In general, climate is studied on a period of 30 years. So most of these are based on a 30-year time period, but that should be labeled throughout the data. Also, under most of them, you're able to show different units. So if you don't want to look in imperial, you can switch to metric. So then we jump into different temperature variables. You can see, again, if you select them, it'll take you down to that option. I'm going to show you a little functionality here in the monthly average temperature. Again, you can switch units here by clicking this button. And if you want to highlight or just take a look at one of the series, like say we want to just look at average temperature, you can take the high and low off and the graph will dynamically update. I believe some people call these the hamburger menu, but in these three lines up here, it gives you options to view in full screen, print, or download in different image formats. So we have another table here, and we also have kind of an average on here showing temperature departures as well. So like I said, I'm not going to go through all of these graphs here, but there's a lot of really great information in here. And then after temperature and growing season days, which is great for our agricultural friends, we jump down into precipitation. And it's the same kind of functionality on the graphs with the options to print. You can switch from inches to centimeters. And again, you can highlight different series of interest. This little arrow over here can take you back to the top when you're ready to move on to something else. So now we're going to take a look and back to the home page, and I'll clear here. I am going to take a look at the division and kind of walk you through one of those. So you can see I selected that to show again, and I am going to select Southwest Lower Michigan here, open in a new tab, and this is one of our station climatologies. So again, it starts out with an overview, talking about what counties are included, what watersheds, a little bit about the climate of the area. These climate divisions were developed by GLISA with partnerships with the Midwest Regional Climate Center and the Office of the Michigan State Climatologist. The information is similar to the station climatologies, but with a few less data sets. So again, starts off with the overview, and then we have similar tables and charts from the last one. Same functionality where you're able to switch units. Again, you can look at just the deviations or the average, and we have the seasonal temperatures. So similar temperature and precipitation data. And we can jump back up with that same arrow there. And lastly, we are going to take a look at some of our Great Lakes climatologies. I am going to select Lake Michigan because I feel like we're on a Michigan theme for very good reason. Okay, so this is our Great Lakes climatologies. These are a bit more in-depth. They include the overview section like the others, and also a lot of great links to other GLISA resources we have on the lakes. These resources will take you to other pages that do talk about the system in general and not more specifically individual lakes, but a lot of really great information in there that my colleagues keep up to date. So the overview has a little bit more information about the lake itself, a map showing kind of inflows and outflows to give you a little bit more background on the lakes themselves. Also, one thing about these Great Lakes climatologies that I think is really helpful, they have a lot more narrative based. So you have the statistics and you have the graphs and the tables, but you also have short narratives to give you a little bit more information. So we have information on lake levels. I'm going to go through this quickly. So we have lake levels through here, quite a few different ones, and then net basin supply, broken down into the different variables that go into that. So precipitation, runoff, evaporation. Again, each one comes with this nice narrative and links to other pages on GLISA for more information. You can see there's a lot more on these pages. So I highly recommend you take some time to do a deep dive in here and see what all we have to offer. These are the Great Lakes climatologies. Our next tool is our CHAMP tool, and I'm going to refresh here so you can see what it looks like when you open it up. Okay, so this is CHAMP, or the Climate and Hazard Mitigation Planning Tool. This tool was co-developed by the Urban Sustainability Directors Network and community partners of 3 of the Regional Integrated Sciences and Assessment Teams, GLISA, CISA for the Carolinas, and MARISA, the Mid-Atlantic. Note, these are now all called CAP teams, but at the time, you can see the logos up here. This was when we were the RISAs. This tool was developed to communicate potential vulnerabilities to residents and authorities responsible for allocating resources for mitigation activities, and to help local hazard mitigation, infrastructure, and land use planners integrate climate information into their hazard mitigation planning efforts. One of the main use cases the developing team kept in mind was FEMA-required hazard mitigation plans. These are required for state, local, and tribal governments to be eligible to receive federal disaster mitigation funds. CHAMP provides an interface for those working in the mitigation field to more easily access reliable, localized climate data to incorporate into those plans. So this viewer allows users to select different climate metrics, projections, and hazard data to see represented on the map, and also see it in graphical form. So all of the states that are colored have data. It extends out of the Great Lakes region, given the partnership that developed this tool. So I'm going to go through some of the basics and do 2 quick example walkthroughs to familiarize with this tool, but I do want to say there's a lot of information in this tool. So kind of like the Great Lakes climatology, I recommend you jumping in here and playing around a little bit, and you're more than welcome to email me if you do that, if you have any questions. So this is how the tool will look when you get in here. You have this nice get started window over here that talks about kind of how to approach this tool. The search function and the information button are both referenced here. So I'm going to show you the information button over here first. This talks about the purpose of the tool, which we just talked about, how to use the tool, which we'll go over here shortly. Data and technical information, kind of where the information's coming from. And then there's also a link to the CHAMP report. That's a really deep dive into the tool. Up here, we have the search function. So similar to the Great Lakes climatology, you can type in your location of interest and it will jump to where you need to be. In our selection panel, we have different climate and weather themes up here that you can select. And within each of those, we have different hazards. So there are the climate metrics and projections, which will be kind of the measurements and annual data, and then hazard types, which are more of event records. So I am switching gears a little bit, and I am going to show you where I'm coming from today. And I am recording in Cleveland, Ohio. So as I search there, you can see that it zooms into my area of interest. If I highlight over, it'll talk briefly about an overview. So right now we're in the extreme rainfall and flooding theme, and we're looking at days with precipitation over 1 inch. The decades we're looking at are from 81 to 2024, and I'm in Cuyahoga County. So you can see the brief trend there with the overview. I do want to point that you are able to change the time range up here. You can see it is dynamically changing while I move that bar. It is capped at a 20-year minimum because, again, climatology, we look at a larger scale to see the trends a little bit more clearly. So now that I'm here, I'm going to click on the county. It'll zoom in a little bit, and you notice this pop-up has updated. So you can see the county details. It talks about that trend that we saw in the hover pop-up, the source of the data, and then also a regional overview. So this talks about kind of the Great Lakes region as a whole and what kind of trends we've seen in relation to extreme rainfall and flooding. Down here, we have options to look at historical data and projected data. I'm going to click this historical data here, and this pulls up our time series. So this is showing, again, the time period, how many days of precipitation over 1 inch we've had in Cuyahoga County. Similarly, we have that hamburger menu or the 3 lines, and that lets you view the chart larger, download the image, or download the chart data. We also have some projection data. When you're looking through the themes, you'll see kind of what projections and metrics have the future data. They do not all have the future data, like the hazards. Those are more of a historical record of events. But the ones that do, you're able to see a graph of projected changes from 2025 to 2099 under a high emission future and also under a low emission future with the same capability to save that model data time series if you're interested in it. All right, so we're going to zoom out here and do another example. I am going to jump down to extreme heat. I do want to make a note that because the area of coverage with this tool is a little bigger, tropical storms and hurricanes, and also coastal hazards, those in relation to this tool are more for the Atlantic states. I realize we have coastal hazards of our own in the Great Lakes, but this is more aimed towards those Atlantic states. So we are going to switch over to extreme heat. And in the hazards, I want to take a look at one of the hazard types. So this is excessive heat. You can see this gives you an overview kind of where it's been a little hotter over the decades. So I'm going to come down into Illinois here. And you can hover around and see the difference. I'm going to take a look at Cook County. So you can see again, they've experienced 11 reported events in our time of interest. So this has updated over here again, that same overview, a definition of what excessive heat is. We can see the regional overview, and then we can also take a look at the annual data. And this is showing when those events happened. I'm going to close out of here, and I want to highlight that in these hazards, you can also decide what impact you want to look at. So we're looking at total reported episodes. We can also look at reported property damage, and that'll talk about kind of the price, and you can see it change with time. Okay, it looks like I chose those couple years, but that is a brief overview of CHAMP. Again, there's a lot of really great information in here, so I highly recommend taking some time to look over those different tools so you can see what all this tool has to offer. And with that, that's the end of my tool tutorials or quick overviews here. I realize that this is not a live presentation, but I want to throw my contact information up there in case you have any questions on GLISA or the Great Lakes Climatologies or CHAMP or any other tools or resources you may find on our website. My email is there. Please feel free to reach out if you have any questions. I have our GLISA website there and also a QR code that will get you there a little quicker if you have your phone ready. And before I wrap up, I just again want to say thank you so much to the team for letting me be a part of this. I hope you all have a wonderful week, and I really appreciate the opportunity to speak with you all today. Thank you.